Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will resume explaining chapter 1 in this course, which is about introduction to mobile wireless and networks. We have reached this slide, which is about communication networks and network sections. So basically, we have three network sections. We have the network edge, where you have the end user devices, like the PC, laptop, desktop, a printer, fingerprint, scanner, etc. In addition to the edge, network edge, we have the network access. The network access is how these end user devices connect to the network. How these devices are connected to the network. Are they connecting via wired or wireless? So some devices are connected via wireless to the access point. Some of them are connected wired through UTP Cat6 cable, which is a copper. It's connected to switch. So some of them are connected wired, some of them are connected wireless. This is the type of access, in addition to other access technologies. So, and the third section is the core. Here, the network core, it contains there are three switches. There are three core switches. It contains the routers, like you see here in the picture, and it contains the firewall. So basically, we have three network sections. The edge section containing the end user devices, the access, which define the type of access, is it wired or wireless, and the core section. So communication networks. In communication, we have different access networks, not only wired and wireless. We have explained that some devices are connected via wireless local area network, WLAN. WLAN that connects end system to route via base station, like access point. But we have other types of communication networks. We have the cable and DSL. The cable and DSL both are high bandwidth and always on. What do we mean by always on? We mean that these devices are always available. Not like the cellular, it is only available when we have a cellular signal. No, the cable and DSL give high bandwidth and they are always available. But the difference is that in the cable, the internet connection is offered by a cable television service. So the cable is used for TVs and it connects TVs using coaxial cable. So whereas the DSL, it is internet connection that runs over a telephone line, like the copper wired. So this is the difference. One is a coaxial cable used for television, and one is internet connection that runs over the telephone line. The fourth type of access network is the cellular network, where your mobile phone and cell phone connects to the ISP base station, like Ooredoo and Vodafone base stations. This is only available where you can get a cellular signals. In some urban areas, in some rural areas, there is no signal, there is no infrastructure. So here comes the role of the satellite. The major benefit of the satellite is in rural areas, which doesn't have infrastructure for internet service providers. So here, the easiest option is to use the satellite to cover this area with internet and cellular coverage, with internet coverage. Top. In the core network, we explained that we have routers. And here we do routing, like OSPF, EIGRP, RIP, ISIS, and other types of routing protocols. What's the goal of routing? What is the purpose of routing? The routing determines the source to destination path, the best path from source to destination. For example, if PCA is sending us a message to PCB, routing protocols determine the best path from PCA to PCB. What is the best path? And what is the second best path, the backup? So here comes the role of the routing algorithms for selecting the best path. We have different routing algorithms. We have the OSPF, which is open vendor. It is used by any routing, by any router. We have the EIGRP, the Enhanced Interior Gateway Routing Protocol. This is Cisco proprietary. It is only used on Cisco devices. We have the RIP. It's not widely used anymore. And we have the ISIS and other routing protocols. And here, when we discuss the routing, here it's good to mention the packet switching. and the difference between packet and circuit switching. So previously we used to have circuit switching. When we say circuit switching, think of a phone call on all landlines. Think of a phone call on all the landlines. Before communication starts, before a call is set up between user 1 and user 2, a dedicated path circuit is established between the two parties. So this path stays reserved for the entire call, even if no one is speaking, till the call is cut, till, till they close the line. So there is dedicated path circuit is set up between the two parties. This path stays reserved for the entire call. It, it is like booking the whole road for your car. As an example, it's like booking the whole road for your car until you reach your destination. No one else can use it even if you stop midway. This is the circuit switching. The packet switching, it is used by internet. Here in this figure, we have routers which use packet switching. It's used by internet. Data is split into packets. Data is split into packets. It is segmented. And each packet can take different route to reach the destination. So basically here, there is no dedicated path. The network is shared dynamically. More efficient, it's more efficient than circuit switching because the bandwidth is used only when the data is actually sent. As an example of this is the email, web browsing, video streaming. So, as an example, this is similar to like sending letters through a postal system. Each letter, in our case, a packet, may take different route, but eventually reaches the same address. Each letter may take a different route, but eventually reaches the same address. So in circuit switching, there is dedicated path and there is continuous connection, whereas in packet switching, there is no fixed path. Data is split into packets that share the network. So the main difference between packet switching and circuit switching is that the packet switching divides data into packets. It divides data into packets that are routed independently based on destination addresses without reserving a dedicated path. In contrast, opposite to this, the circuit switching, which establish a dedicated connection for the duration of a call, with reserved links and consistent path for data. So, what is the internet? The internet is a network of networks. It is a worldwide collection of interconnected network types. So LANs are connected using WANs. You can see here, in home I have LAN, in school we have LAN, in business, in hospital, in government we have LANs. How are these LANs connected? Through WAN links. And the WAN links are connected to core switches, and the core switches are connected to each other using WAN links. So LANs are connected to each other using WANs. WANs are then connected to each other using copper wires or fiber optic or wireless. So what is the internet? It is the network of networks. Network of networks. And here, when we speak about internet and network, there is a need for multi-layers and standards like the OSI. You know the OSI, Open System Interconnected. It consists of 7 layers. So the OSI layers, the Open System Interconnected, it consists of 7 layers. How the PC is sending a message to server A is going through 7 layers: application, presentation, session, transport, network, data link, and physical. Application, presentation, session, transport, network, data link, and physical. So when PC1 sends hello, the hello is transmitted into bits and it goes through these layers. Now we will be speaking about each layer in details. Let us start by layer 7, which is the application layer. What it does, the application layer, In the application layer, the applications talk to the network. They speak to the network, like web, email, file transfer. So think like user-facing protocols and data formats. As an example of application layer, you see here we have protocols like HTTP and HTTPS. When you browse the web, you use HTTP or secure HTTPS. And when you browse the web, you browse it with the name. For example, www.google.com. We write google.com, we write the name. Then the domain name service, it transforms the name to IP address. Because we cannot memorize all the IP addresses for all the websites, it is easier to memorize the name. Then the DNS, its role is to convert from the domain name to IP address. Also, this is in the application layer. Also, we have the SMTP, the Simple Mail Transfer Protocol, which is used in emails. This protocol is used for emails. And the File Transfer Protocol, which is used during file transfer. This is also in the application layer. And the Dynamic Host Control Protocol. So this is the 7th layer. And the presentation layer, the 6th layer, what it does, it makes data understandable for applications. So it transforms, as we have seen here, it transforms the word to binary. It transforms data to binary. Hello is transformed here to binary representation. It makes data understandable for applications. So it translates, encrypts, and compresses data. As an example on this is the TLS and Secure Socket Layer, SSL. The session layer, it opens session between applications. So what it does, it starts, manages, and ends conversation between applications. It keeps the session going between applications, keep the dialogue going between applications. Like what? Like video calls, online games, a remote session. If I'm doing remote desktop from one PC to another, I need a session. The 4th layer is the transport layer. And here we speak about end-to-end delivery between the processes. Here we speak about segmentation of data and reliability. And the two popular protocols in this layer is TCP and UDP. Which is more reliable? TCP. Which is more faster? UDP. What is the difference? The TCP is the transmission control protocol. It uses a three-way handshake. So basically, if PC1 sends sync message to PC2, I need to open a connection with you. PC2 will reply by sync acknowledgement that I received your sync. Then PC1 will reply by acknowledgement. He acknowledges the sync acknowledgement. So he replied by acknowledgement to PC2, which means I received your sync acknowledgement. I will repeat. PC1 will send sync message to PC2. PC2 will reply by sync acknowledgement. Then PC1 will reply by acknowledgement. Here, they open a connection before transmission to make sure that the transmission is reliable. In UDP, User Datagram Protocol, it is like fire and forget. They will send the data and they will don't care if it is received or not. This is faster. This is used on YouTube videos and videos. You can see in some videos there is disconnection. Some videos are intermittent. Why? Because some data is lost during transmission. In UDP, we don't care about reliability rather than caring about the speed and how fast the video is. In network layer, layer 3, here what it does, it focuses about routing, which is finding the best path across network. And when we speak about network layers, not only we mention router, we mention IP addressing. And here, the data sent between the two routers, we call it packets. We send packet from router 1 to router 10, for example. From router 1 to router 3, we send a packet. As an example of network layer, the IP addressing, the internet control message protocol, which is used for the ping. The ping, when we ping from one PC to another, we use this protocol, Internet Control Message Protocol. An example of routing there is the OSPF, BGP, EIGRP, which are the routing protocol. OSPF is Interior Gateway Routing Protocol used inside the autonomous system. BGP is Border Gateway Protocol. It is used between the autonomous systems. It is exterior. And both are examples on network layer. So in the data link layer, here we don't speak about routing, we don't speak about IP addressing. Here we speak about the switches and MAC addresses. So this is hop-to-hop delivery on the same network, same LAN, same local area network, same VLAN. So when switches are when PCs are connected to the same switch, when PC1 sends message to PC2, the traffic goes through the switch. How the switch identifies which is PC1, which is PC2, which is PC10? Based on the MAC address. Based on the MAC address of these PCs. And all these PCs are connected via wired, via Ethernet to the switch. Or two mobile users, laptop and mobile or iPad, connected to this wireless access point in the same network. Here we speak about wireless. They are connected wireless, and this is the standard for wireless, IEEE 802.11. For sure, there are different Wi-Fi standards, Wi-Fi 5, 6, 7. So 802.11, it differs whether 802.11n or AX, etc. It depends. So there are different Wi-Fi standards. Physical layer, what it does, it moves the bit, converts the bit to electrical signal or optical or radio signal to pass through the physical medium. Either it converts it to electrical signal to pass through UDP, or optical signal to pass through optical fiber, or radio signal to pass through wireless through wireless medium. So it defines cables, connectors, and timing. An example of physical layer is the UTP copper cable, Cat6, fiber optic cables, and Wi-Fi radio signals. So here is the slide. It is showing all the physical layers, all the 7 layers. So the last layer, the 7th layer, is the application layer. It describes the format of requests and responses between clients and servers. The presentation converts data to binary. It is responsible for data translation, encryption, and compression. Session, it opens sessions between two different applications. Transport is responsible for end-to-end communication, whether it is with optional reliability. We can use TCP, we can use UDP. Network, here in this layer, we care about end-to-end routing of packets from one source to another. For data link, here we can care about exchanging frames. So here, look, here in network 3, we call it packet. We are moving packet from router to another. In data link, we say frames. We are moving frame. We are sending frames from PC1 to PC2 via switch, through the switch. And the physical layer, it describes the electrical and mechanical and procedure means to transmit binary bits using physical signals across connections. Here is an example on the OSI 7 layers. In the application layer, here I'm using my Microsoft Outlook as an email client, to set up the message. So I prepare the message and I want to send it. Once I use the Microsoft Outlook, this is an example of the application layer. Then the email is formatted as encrypted, a presentation layer. Then a session is opened with the email server. This is the session layer. Then the email is divided into segments and sent reliably using TCP, because here I'm sending email. In the network, the email segments are routed through various routers till we reach the destination based on the IP address. We reach the destination router based on the IP address. Then the router forwards it to the correct VLAN, to the switch. Then the switch forwards the frame to the required PC based on its MAC address. Then the physical layer, here the segments are transmitted as electrical signals over the network medium, whether it is wireless or wired. So here is the Internet Protocol stack. What we have explained previously is the OSI layers, which are about 7 layers. They are 7 layers. But here the TCP/IP, there are 4 layers: the application, transport, internet, and network access. Here they mentioned, instead of internet, they mentioned network, and instead of network access, they mentioned link. Okay. And they added the physical. Why? Because here in wireless communication, the most important layer for us is the physical layer. The most important layer for us is the physical layer, then link layer. When we speak about wireless communication, then this means that we are interested in these 2 layers, the physical layer and the link layer. Here is an interesting slide. What is the name of the protocol data unit, the PDUs, in each layer? In the application layer, we called it data, user data. User data, it is a message, okay? In the transport layer, we call it segment. We segment the data. In the internet layer, we call it packet. In the link layer, we call it a frame. Then, in the physical layer, we call it bits. Here we convert bits to electrical signal, which passes through the physical medium. So in wireless communication, we are interested about these 2 layers, the physical layer and the link layer. Okay. Now we will speak about an interesting technology, which is the broadband. What is the broadband? In your opinion, what is the broadband? And what is the main benefit of the broadband? First, from its name, it is a broadband and not narrowband. It is not narrow band, it's a broadband, which means wide bandwidth data transmission. It's wide bandwidth, not narrow bandwidth, which transports multiple signals and the traffic types. Here, when we say broadband, we speak about high data rates, which is obtained with wireless broadband technologies. And the main advantage of the broadband is the mobility. It is the same advantage that all wireless devices share, mobility. So service can be deployed faster than fixed service. There is no need to pull fiber to your building and to your floor and then do the required cabling and connections and then connect it to the fixed router at your home. No, there is no cost of cable plant. Just you buy the device, broadband device, and the SIM. And the main advantage is that it is mobile and deployed almost anywhere. And when we speak about broadband or wireless in general, we care about 2 things. We care about capacity and bandwidth. We care about capacity and bandwidth. The link capacity, which is called digital bandwidth here, link capacity, it is how many bits I'm sending per second. How many bits I'm sending per second. So it measures the amount of data that can flow from one place to another in a given amount of time. So units is in bits per second. Here we are interested on how many amount of data you are sending in a given amount of time. So bits per second, this is the fundamental unit of capacity. The kilobits per second, it's 1000 bits per second. The mega is 1 million. Giga is 1 billion. Terabyte is 10 power 12 bits per second. These are the units that can be used for capacity. As the capacity is higher, this is better for your network. And we also mentioned the bandwidth. In radio frequency transmission, which is the RF transmission, the bandwidth is the difference between upper frequency and lower frequency. So F2, which is the upper frequency, minus F1, which is the lower frequency, in a continuous band of frequencies. And this bandwidth is measured in hertz. is measured in hertz, which is the number of cycles per second. Number of cycles per second. So our goal in the telecommunication is to maximize capacity and maximize bandwidth and minimize delay and use error correction and recovery mechanisms. So our goal in wireless communication is to maximize the link capacity, maximize the bandwidth, and minimize the delay, and use error correction and recovery mechanisms. If the capacity is low, then users will start facing issues and delays and signal losses. Here is the definition of wireless communication that we explained earlier. That is the transfer of information between two or more points. Up to here, it is communication. A transfer of information between two or more points, it is communication. When we say that are not connected by an electrical conductor, then here we are speaking about wireless communication. So, wireless communication, what is wireless communication? Wireless communication, it is the transfer of information between two or more points that are not connected by an electrical conductor. And here we are speaking about electromagnetic waves. Who can tell me what is an electromagnetic wave? What is an electromagnetic wave? The electromagnetic wave, it is an electric and magnetic, it consists of electric and magnetic fields. So the electromagnetic wave, it consists of electric and magnetic field. Electric field and magnetic fields. And both these fields are orthogonal to each other. So there is the right angle between the electric field and magnetic field. So the wireless signal which is transmitted between the mobile station and base station, it is electromagnetic wave. It consists of electric field and magnetic field. Both there is a right angle between them. Both are orthogonal to each other. There is the right angle between them. So they are synchronized oscillations of electric and magnetic field. How the electromagnetic signal is represented? It is the amplitude cosine 2 pi ft plus epsilon. A, which is the amplitude, cosine 2 pi ft, f is the frequency here, plus epsilon. Now I will show you different electromagnetic waves and how the amplitude varies, how the frequency varies, how the phase shift varies. So we will speak about these properties in the electromagnetic wave. Okay, let us start. This is MATLAB file. We simulate the electromagnetic signal with different amplitude. I will run. I will run the program. And here you can see the signal for three electromagnetic waves. Both are having the same frequency but different amplitude. The smallest amplitude is for the blue electromagnetic wave signal. The second one is the green electromagnetic, is the red electromagnetic wave. And the electromagnetic wave that is having the highest amplitude is the green one. So basically we measure the amplitude from the x-axis to the top of the signal. So the highest amplitude is for the green signal, then the red signal, then the blue signal. Let us simulate a program for electromagnetic wave with different frequencies, like this. So these two, they have the same amplitude. The green and the blue signal, they have the same amplitude, but they differ by frequency. What is the frequency? It is number of cycles per second. Number of cycles per second. Here you can see a number of cycles per second. So here you can see the green signal is making a lot of oscillations, greater than the blue signal, which means it has higher frequency. You can see the oscillations for the green signal. It is larger than the blue signal, which means it has higher frequency. But the blue signal has a higher wavelength, a higher lambda. What is lambda? It's the physical distance between from peak 1 to peak 2. From peak to peak. The distance from peak to peak is lambda. It is called wavelength. As the frequency decreases, like in the case of the blue signal, the frequency is smaller, but wavelength is bigger, larger. For the green signal, the frequency is higher, but with the wavelength is smaller. See, it's from here to here only. So as the frequency increases, wavelength decreases. As the frequency decreases, wavelength lambda increases. You know the formula, C equal lambda f. C equal lambda f. C is the speed of light, and it is the speed of electromagnetic signal in vacuum. It is the speed of electromagnetic signal in vacuum, of electromagnetic wave in vacuum. C, 3 times 10 power 8 meter per second, the speed of light, and it is the speed of electromagnetic wave in vacuum. As the frequency increases, lambda decreases. As lambda increases, frequency decreases. But C is constant. It is the same. There's not a change here. Okay, let us continue. So, wireless communication is here. We are repeating the definition. It is the transfer of information between two or more points that are not connected by an electrical conductor. So, here the mobile is transmitting the signal, and the base station is receiving the signal. At the same time, the base station is transmitting a signal, and the mobile station is receiving the signal. So here the mobile is the transmitter and receiver. We call it a transceiver. Transceiver device, it consists of both transmitter and receiver. Okay. Now we will come to an important slide and important concept in wireless communication. One of the most important concepts in wireless communication is the modulation. What is modulation? Who of you heard of modulation before? Let me explain it for you. If you need to move from one country to another, is it enough for you, for example, if you need to move from one country to another, is it enough for you to jump? No, because in this way you cannot reach the destination. But if you use a carrier, like an airplane, which is fast and goes high on a high altitude, you can travel from one country to another. The same concept happens here. The baseband signal, it is of low frequency. The baseband signal, it is the original signal which contains the information to be transmitted. This baseband signal, the original signal, it is of low frequency, like the baseband signal here, which consists of 1 of 0 and 0. So this baseband signal cannot be transmitted from transmitter to receiver. I cannot send it through the air. It contains the information, but I cannot transmit it like this through the air. I need to put it on a carrier signal, and the carrier signal will be transmitted from transmitter to the receiver. But not also I put the baseband signal that contains the information on a carrier signal. Also, I need to change one of the properties of the carrier signal. I need to change the frequency by using phase modulation. I need to change the amplitude by using amplitude shift key, ASK for example, or I need to change the phase. So modulation, it is the process of varying one or more properties of a carrier. It's the process of varying one or more properties of the carrier signal. Either I vary amplitude or frequency or phase using a separate signal called the baseband signal to transmit information. So the baseband signal, which contains the information to be transmitted, I put it on a carrier and I change one of the properties of the carrier, amplitude or frequency or phase, then I send it through the air. The outcome of this process is the modulated signal, which is then transmitted. So I don't send the baseband signal, I send the modulated signal. I will repeat, we put the baseband signal on a carrier signal to be transmitted, and we change one of the properties of the carrier signal. Then the resultant is modulated signal, which can be sent through the air. Here, you can see here there is also a block diagram which gives extra information. Here, the source information is sent through the source encoder, a channel encoder. And then here comes the role of modulation, which sends the modulated signal to transmitter antenna coupling. And here there is the channel where the signal is transmitted in air, and the channel from transmitter to receiver. After that, we make demodulation. We extract the original signal. After making a channel decoder and source decoder, we can extract our original signal. And you can see here on the left, we use the modulation technique frequency shift key, which means I'm using this to as our modulation technique. So basically for baseband signal, we have 1 and 0 bits. So for bit 1, I used a frequency, the higher frequency, I used F1, modulated signal with higher frequency. And for bit 0, I used the modulated signal, but for lower frequency, F0. So once I receive the modulated signal at the receiver, from this signal, I will come to know that the modulated signal having the higher frequency is bit 1, represents bit 1, and the modulated signal having the lower frequency of 0 represents bit 0. Here is an example, but here we have 4 bits, 1, 0, 0, 1, using frequency shift key. So for bit 1, I'm using the modulated signal with higher frequency F1, and for bit 0, I'm using modulated signal with lower frequency F0. So this channel is being sent over the transmission medium from transmitter to receiver. But here I modulate it. I don't send this 1001, I send the modulated signal with F1 and F0 properties. What is the benefit of wireless networks? We mentioned that one of the benefits of the wireless network is the mobility. Okay. It is also significantly lower cost. Lower cost compared to what? Compared to wired. Compared to wired, because there is no cable implant, there is no cable installation, low labor cost and low maintenance. It is easy, scatter and play, unrestricted mobility, this is the most important, unplugged from power outlet, and ubiquity. Ubiquity means واسع الانتشار, means pervasive. واسع الانتشار, widely spread. widespread. So ubiquity is like pervasive. It is widespread. It is available like water and electricity. It is available like water and electricity. And when we speak about networks, we need to speak about wireless network types, and we need to speak about the electromagnetic spectrum. This is very important that at least I give you an idea on it in the introduction to mobile and wireless. Here you can see that I don't have only one band. I have many frequency bands, right? Here you can see on the y-axis, I have frequency bands from 3 megahertz to 3 terahertz. From 3 mega to 3 tera. So there is high frequency, very high frequency, ultra high frequency, super high frequency, extremely high frequency, and infrared. And the high frequency, it's from 3 megahertz to 30 megahertz. Here we have applications like short wave radio, international broadcasting, amateur radio, etc. In the medium, in the very high frequency, we have applications like FM broadcasting, television, two-way radio, etc. In the ultra high frequency, we have applications like UHF television, cellular networks. Here we have cellular networks. We have GPS, Wi-Fi, Bluetooth. Basically, Wi-Fi, it has three frequencies: 2.4 gigahertz, 5 gigahertz, and the new one is 6 gigahertz. We have 2.4 gigahertz, 5 gigahertz, and 6 gigahertz. 6 gigahertz. So both 2.4, 2.4 and 5, and also 6, they are used for wireless. As we have explained before, as the frequency increases, wavelength decreases. So the signal does not propagate too much in a long distance through the air. So in 5 gigahertz, it's better for you to use because it gives you a higher speed when you are fixed in your place, when you are sitting in your place near the router. So if you are sitting at home fixed in your place near the router, it's better for you to use the 5 gigahertz frequency because it gives faster signal. It is faster than 2.4, but the coverage is lower because lambda is smaller than the lambda in 2.4 gigahertz. The coverage is smaller. And 2.4, the frequency is less than 5, so the speed is less, but the coverage is larger because we have high wavelength. Although the frequency is lower than 5 gigahertz, but we have a higher wavelength, so the coverage is higher. So if you are sitting in your place near the router, use 5 gigahertz. It is faster. If you are roaming in home, you are moving in home, then it is better for you to use 2.4 gigahertz to have better coverage. So for super high frequencies, we have here the applications like the satellite communication, microwave, link, radar, and some Wi-Fi, like 5 and the 5 gigahertz and 6 gigahertz. And the extremely high frequency from 30 giga to 300 giga, we have the advanced radar system. We have some high frequency. We have the advanced radar system here. So let us continue. This is the electromagnetic spectrum. Here you can see the spectrum from frequency equal 3 hertz to 30 hertz. You can see in the spectrum as the frequency increases, as the number of oscillations here increases, wavelength decreases. So when the frequency is 3 hertz, the wavelength is 10 power 8 meter. When the frequency is 30 Hz, the wavelength is 0.01 nanometer, 10 power minus 9 meter. So the frequency is higher here. You can see the number of oscillations are higher, number of cycles per second are higher, but the wavelength is too much small. So the frequency works opposite to the wavelength. As the frequency increases, wavelength decreases. As wavelength increases, frequency decreases. And here is the radio spectrum, up to 300 gigahertz. This is the radio spectrum. And here, there is the millimeter wave. Between 30 gigahertz and 300 gigahertz, we have the millimeter waves. These waves will be used in 5G system, 5G networks, which is between 30 gigahertz and 300 gigahertz. Above 300 gigahertz, we have the terahertz, which is between 300 gigahertz and the 3 terahertz. This terahertz band will be used in 6G communication system. Okay? In 6G communication system. Then we have the infrared visible light, ultraviolet, the X-ray, this is famous, and the gamma ray. I need to note that the frequency of the microwave is close to the frequency of the Bluetooth. So when you use the microwave to cook the food, you use similar frequency that you use it in the Bluetooth, close to it. But in the microwave, it has a high power. For this reason, when you put the food in it, then after some time, you will have it ready and hot. Because here, we use high power. But it's the same frequency that is used in the Bluetooth, similar. So those who use the Bluetooth day and night and put it for long hours, it is risky for them. It is not advisable to use it for a long amount of time. Although the power is smaller than the microwave, but using this Bluetooth for the long time, it may hit back. It has some drawbacks. So it's better to take precautions in this case. Now, let us continue. Here we mention about the network types. What network types we have? We have the PAN, we have the LAN, we have the MAN, we have the WAN. The PAN is the wireless personal area network. Like what? Like Bluetooth or Zigbee. Wireless personal area network. On the personal level. It is used for few meters, the Bluetooth technology. Then, wireless LAN is larger. It is used in wireless local area network, so basically inside a building. WMAN, it is wireless metropolitan area network, which is used across a city. Then the largest is the wireless WAN, wireless wide area network, which is used across the world. Okay, an example of wireless WAN is GSM, 2G, WCDMA, 3G, LTE, which is the 4G cellular system, which is based on MIMO of the technologies that we will explain in chapter 3. 5G, 6G, satellite, all these are examples of wireless WAN. Let us focus on the PAN, wireless PAN. We mentioned that we have two technologies, the Bluetooth and Zigbee. What is the difference between these two? A Bluetooth is used for general short-range data exchange. It is used for short-range data exchange and operates between 2.4 gigahertz and 2.485. So it is a wireless technology, well-known wireless technology for exchanging data over short distance, and the frequency ranges from 2.4 to 2.485. Zigbee, it is designed for low power, low data rate applications. It is designed for low power, low data rate applications such as home automation. It operates at 2.4 gigahertz and it is based on IEEE standard 802.15.4 standard. Here you can see the different and various types of wireless local area networks. You can see the different types of various wireless local area networks. This was the start of wireless networks. It is 802.11b. So all 802.11 refers to wireless, but here B is the Wi-Fi standard which was established in year 1999. 1999. The data rate was at that time, the transmission rate is 11 megabit per second. Then in 2003, the 802.11g was established, which reaches speed levels up to 54 megabit per second. Then the N was established in year 2009, and it can reach a speed up to 600 megabit per second. Then Wi-Fi 5. Wi-Fi 5, which is the standard 802.11ac. 802.11ac. It can reach speeds up to 1.3 gigabit per second. This was established in year 2013. In 2019, 802.11ax was established, Wi-Fi 6, which can reach speeds up to 9.6 gigabit per second. Then Wi-Fi 7. Wi-Fi 7, which is 802.11be. It was established in the last year in 2024, and it can reach speeds up to 46 gigabit per second. Here you can see the evolution in wireless communication. How the standards are developing and how this transmission rate is increasing from 11 mega to 46 gigabit per second. So this is for wireless LAN inside EbelLink. For wireless WAN, we can speak about cellular networks like the 3G. The 3G, let us start by the 1G. In the first generation cellular system, the speed was about 2.4 kilobit per second. In second generation, the speed reached, it varies between 50 and 100 kilobit per second. In third generation, which is the WCDMA, the speeds ranged between 1 megabit per second and 3 megabit per second. Then, in 4G, LTE, long-term evolution, the speeds reached up to 100 megabit per second. In 5G, which we are currently using, the speed can reach up to 10 gigabit per second, several gigabits per second. And in 6G, it is expected that the speed can reach 100 gigabit per second. So this is, for your knowledge, this is an important information and the interesting information that shows you how the wireless technologies and cellular technologies are evolving and how the transmission rate is increasing from one generation to another. The edge of the network is becoming wireless. We have single hop networks, we have multi-hop networks. What is the difference? A single hop networks have direct communication between source and destination, whereas in multi-hop networks, it uses intermediate nodes to relay data between source and destination. Here, we'll speak briefly about Internet of Things, which is the network of physical objects. For sure, we have one dedicated chapter for Internet of Things, but to define it, it is network of physical objects. So everything is connected to Internet. The laptop, the iPad, the camera, the desktop, the car, the light, the fridge, washing machine, refrigerator, camera, everything is connected to network. There is sensor and through the sensor it's connected to network. So the Internet of Things, IoT, refers to the network of interconnected devices and sensors that communicate and exchange data over the internet. And here it's important to mention the RFID technology, which is radio frequency identification. It is a technology that uses radio waves to automatically identify and track objects. So this RFID, it uses radio waves to automatically track and identify and track objects with embedded tags. And here comes the end of our lecture. Assalamu alaikum wa rahmatullahi wa barakatuh. If you have any question, please don't hesitate to send me email.